Everyone, I am Mohaminul. I will present our paper Propose Assess Search Harnessing LLMs for Goal-Oriented Planning in Instructional Videos. Goal-oriented planning aims to generate action plans to achieve a given goal based on current observations. Depending on the specification of the current observation and the desired goal, the task can be instantiated in two different setups. Visual planning for assistance, where the current observation involves an untrimmed video history of users' progress and the goal is described in natural language. And procedural planning, where the initial and the goal state are presented with images. Learning such a policy from video data is challenging since it requires a comprehensive understanding of procedural tasks, including the temporal and hierarchical interconnections between action steps. Most prior works design specialized architecture for different setups and rely on expensive training data. Therefore, they cannot generalize to new data domains and unseen tasks. In this paper, we propose Feed Assist, an integrated framework for goal-oriented planning in instructional videos. Our framework utilizes LLMs for better generalization in zero-shot and few-shot scenarios, since LLMs are pre-trained with internet-scale data and possess extensive knowledge about a variety of procedural tasks. Finally, we propose a search-based framework that empowers LLM with a structured decision-making process and a deliberate planning mechanism to find the optimal action plan. First, we design an LLM baseline for goal-oriented planning. We follow the Socratic model approach to represent visual observations and goals for LLM-based planning. Specifically, we convert visual observations into text forms of action steps using prior action recognition models. Afterward, we prompt a state-of-the-art LLM Llama to predict the most probable subsequent actions. While the LLM baseline method performs well in short-term planning, its performance diminishes significantly for planning over a long-term action steps. We hypothesize that deliberate planning mechanisms to explore a combinatorial space of partial solutions are essential to finding optimal actions plan for a procedural task. The VDSS framework utilizes a propose, assess, and search strategy for generating optimal action plans. Given goal and action history, first we propose several possible actions at each step by sampling multiple times from an LLM to account for the uncertainty in procedural tasks. Each proposed actions is then evaluated using a composite of value function that I will describe in the next slide. Then only top K partial plans are kept for further exploration for efficiency. We repeat this process n times. Finally, we employ a breadth-first search algorithm to identify the optimal action plan according to the assessment scores. We introduce 4 assessment functions to evaluate the partial action plan tailored for goal-oriented planning. This assessment process is crucial for our framework as it empowers LLMs with a deliberate planning mechanism and extends beyond the conventional token-level generations process of LLM. First, partial plan evaluation evaluates the coherence and viability of a partially generated plan using LLMs. Second, text generation score evaluates the probability of an LLM generating a given description. Third, text mapping score is the confidence score of mapping a free-form description to an admissible action. Finally, few-shot task graph introduces task-specific prior knowledge in our assessment method, which is only used in few-shot scenarios. Please refer to our paper for more details on the assessment scores. Datasets. We conduct experiments on 2 widely used instructional video dataset, COIN and Crosstask, for both procedural planning and visual planning for assistance. Evaluation metric. We use 3 evaluation metrics. Success rate evaluates if the predicted action steps and the order match exactly with the ground truth. Mean accuracy evaluates the accuracy of individual action step at each timestamp. Mean intersection over union considers predicted and ground truth action plans as 2 sets and measures the overlap between them. Planning horizon refers to the number of future action steps the model needs to output given the goal and visual observations. Here we present the results of visual planning for assistance on Croyan dataset. First, Feed Assist demonstrates superior performance across all metrics in zero-shot and few-shot setups. Second, our model outperforms the LLM baseline significantly, demonstrating the inadequacy of simple LLM baseline for this task. Finally, few-shot Feed Assist outperforms the state-of-the-art fully supervised methods, showcasing the effectiveness of the deliberate search-based planning mechanism of our approach. Next, we present the performance of procedural planning on Coin dataset. Here, we also observe a similar trend. VDACID performs best in both zero-shot and few-shot setups, demonstrating better generalization ability. Moreover, few-shot VDACIDs outperform the state-of-the-art fully supervised methods, especially for predicting long-term action steps. Here we show one ablation study which compares the importance of different value functions. The LLM based partial plan evaluation achieves the highest success rate when only one value function is used, highlighting the efficacy of LLM as the assessment tool for evaluating partial action plans. Combining all four value functions leads to the highest performance, demonstrating the importance of each proposed value function for goal-oriented planning task. Please refer to our paper for more experiments and ablation studies. Here we show one example of visual planning for assistance in the Coin dataset. Leveraging the propose, assess and search framework, Feed Assist can successfully predict future action steps while the LLM baseline fails. Similarly, Feed Assist predicts the correct action steps in the procedural planning task while the LLM baseline fails, again showing the efficacy of the deliberate planning mechanism of our framework. Thank you, everyone.